All right, so stop video, share screen, electric stuff. I'm sorry. Oh, yes, please. If you guys want to see things, I think that would be very beneficial. Thank you, Gavin. I was showing somebody else things. So let's see, we're going to be working on the beta multiplier layout. Did you guys actually do any work on Monday, or did you say he's not here, I'm not doing it? Okay, that's I figured as much. I just wanted to make sure. All right. So
I have a question though.
Sure.
I was talking with him about this. I'm going to show it to you and not try to hand it to you. Don't want to share the virus too much, but that was the equation I was trying to use to calculate out the I reference, or I'm sorry, the bias, but that bias is just way too high.
not necessarily.
Okay.
It seemed large compared to what we were talking about. Whatever day that was.
So it's large compared to whatever day that was, because whatever day that was, we were using 400 microamps per volt squared. So it was literally 5 times the mu n value was 5 times larger. So 26.5K seems reasonable. Yeah.
Okay.
It's much better than 100K plus, which is what we got for the resistor biasing using that same thing. So that's not bad. Yeah. So before we get to installing the resistor, though, we need to have our startup circuit implemented so that the device actually turns on. And that would require me to have my mouse, which is here. Okay. So we're going to be working on the startup circuit today. So that's the 3 transistors on the leftmost. We have 1 PMOS and 2 NMOSs to do. So I'm going to start with the PMOS all the way over to the left. This is going to be a very long length PMOS transistor. So 10 for the width and 100 for the length. So this guy is going to take up some space. So because its length is so long, I am thinking about things here. I'm going to leave this as is. I was thinking about rotating it 90 degrees, but that's typically bad practice. You want all of your transistors either oriented vertically or horizontally, not a miss. Exactly right. So effectively, if you go back and forth between the two, you're going to get weird variations due to misalignment. At least if they're all oriented in the same direction, you have some means by which to quantify things largely. So I'm going to leave this as it is. And this is also part of the reason why we didn't attach anything to our supply rails earlier, because we don't know how much space we're going to need between them. All right, so we have our 10 by 100. Now we need to add our P active regions. This needs to be 100 long in the Y direction to match. So I'm moving it over here and I am attempting to line it up so that I can connect it to, no, that's not right. It should be 10 wide. Sorry.
I went to attach it and I was like, that doesn't seem right.
Yep, nope. As soon as I started trying to figure out where it was going to go, I was like, oh, that's very much not correct. Yes, and then we're going to scooch it down here, press F5, no errors, and I'm going to also zoom in just for the sake of argument. I'm going to go ahead and do a body connection as well. So that is going to be, let me think about this, an N-well connection up here. It's going to be 10. Like so, and I need to make sure I've lined it up, but that my wells don't overlap. This should be good to go. And those 2 terminals are going to be wired together. like so. Pressing F5 seems legit. I'm going to try to scooch it over 1 unit to the right. It still didn't give me errors. Still no errors. I'm just going to leave it where it was. If they're not giving me errors, I'm just going to leave it the hell alone. And then that's eventually going to get ran up to the supply rail. Now, technically speaking, I might go back and delete this connection and then just run a wide trace connecting that source to that body connection to that supply rail. It'll have less resistance if I use a wider trace that just goes straight up vertically. I just did this kind of serpentine thing because that's what I had done in other places for a similar thing. Because I didn't do this a moment ago, I'm going to label this, actually, sorry, I'm going to set the splice model of this. And this is a PMOS transistor. And I'm going to make that text a little bit larger. And then I'm also going to put some text. So I got a miscellaneous annotation text. Going to drop it down here below. And I'm going to call this MSU for start up. And let's call it 2. And I'm going to make that text slightly larger. Way down here on the bottom, pardon me, I think I'm about to sneeze. Maybe not. I'm going to put a P active to make our connection for our drain. Scooch this guy up, press F5, no errors. And I need my gate and my drain to be tied together for this one. So it's a diode connected device. Thinking about how I'm going to do this, clicking on the gate. Thought I was clicking on the gate, but apparently I wasn't. So how close can I bring this down here? What metal? So that's tying my gate and drain together, and now I'm going to see how close I can get it without it having a panic attack. Metal is too close. And it looks like I'm only half a unit over the line. All right, 0. Okay, so my gate and my drain are tied together. And I'm going to go clear out my previous errors.
And you used one of these metal polysilicon connections between the metal and the gate.
Yeah, this guy, the pink box outside of a purple box, outside of a black box. So that is polysilicon connecting metal 1 through a contact layer. I'm going to label this node here as the drain of MSU2. So annotation text here in the middle, DSU2. Make the size larger. And just for the sake of argument, I'm gonna label these guys up top as well. So this is the body of SU2. And that's not what I wanted. The source of SU2. All right, so we have that really wide transistor done. No, excuse me, really long transistor done. Now we're going to do just the 10 by 2 NMOS transistor. So we're going to call this MSU1.
I'm sorry, I think I missed a step. I was trying to get something to work here. I just finished connecting up the gate to the inactive. What was the next step after that?
Let me see what you have. I just put a new, I just labeled things
Oh, okay. Okay.
Yeah. so that I can remember what I'm doing. Now I've put a NMOS transistor here. I'm going to set it spice model before I forget about it. Dragging that over to the right. I'm going to put a label on it. MSU1. Moving that slightly over. Now I'm going to put the active regions because this is an NMOS transistor. They need to be N active.
What's the width and length?
10 by 2.
Okay.
And where it's located, I can see a lot of overlap with stuff. So I'm pretty much guaranteeing that it's going to give me an error. We have 2 errors. So I think I need to scooch that down a smidge. Yep, no errors now. So this guy is going to be the drain of SU1. I need another N active region down here. This is going to be 10 by 2. Scooch him up. No errors. This is going to be the source of SU2 or SU1, excuse me. And I'm going to put a P-well contact for my body connection down here. 10 by 5. Didn't do it. Oh, I changed its name to 10. I'm going to delete that because that's going to confuse LT Spice later on. P-well 10 by 5. Getting it right here where it's lined up. No errors. This is going to be the body connection. So BSU1, apply, okay. My drain and my body need to be tied together. It's doing the dumb active region instead. So I'm just doing this purely to connect here, and then I'm going to delete this thing right here because I didn't want to have weird metal nodes out in the middle of things. So that's my source and body wired together. And I'm just making sure that text size is the same as everything else. All right, so I have 2 of my 3 transistors for my startup circuit taken care of. Let me scroll up here. So the last one that I have to do is an NMOS transistor that is 10 by 1, because a 10 by 1 would give us an error, and I'm just going to confirm it really quick. So if I throw a 10, leave that blank or it's going to freak out, by 1, press F5, 4 errors. Minimum size on the y-axis is smaller than it can possibly be. So I'm going to change this to a 10 by 2, and then to get the right aspect ratio, we're just going to have 2 10 by 2s connected in parallel. So this is going to be, sorry, let me, an NMOS transistor. That's the wrong thing. Scroll in so we can see it. I'm going to give this guy a label. That is going to be MSU3A. Connect my active regions. Not that it matters, but I'm going to move this down. Connect another active region down here. Now I'm going to throw another NMOS transistor down here. Scooch my transistor up to make it work. Set my spice model. Really wish there was a keyboard shortcut for that. I'm going to give it a label of MSU3B. Give myself another inactive region here at the bottom. Scooch this guy up. All right, so because these transistors are in parallel, I need to wire the gates together. That middlemost area is going to be the common source for both. And then the outside regions are going to be wired together so that they are tied together to be the drain of the device. Okay, so let's see what I'm thinking about here. So I guess I'll just have to put a metal node to do this the way that I want to. So I'm just putting a chunk of metal out here. And I'm going to make it 4 by 4. Connect that to this thing, and I'm making this 4 wide and no extension. Running it down here. And now I'm just going to move this guy over. Scroll down here. I'm trying to see how much overlap I can get. No errors. Okay. All right, so I'm going to scroll out here because I don't have any of these startup transistors actually connected together. Okay. So if I'm looking at the startup circuit portion of things here, let me open up that file. The startup circuit part is right here. So this one up top was 2, 1, and then this guy right here is 3, which we made by putting 2 10x2s in parallel, which looks like a 20x2. 20x2 has the same ratio as 10x1, which is why we did it. I have my drain and gate of 2 connected together. That needs to be connected to the gate of 3. So I am going to facilitate that by moving this whole transistor up. I'm going to click on this polysilicon node and click on this polysilicon node over here. And now I'm going to see what happens so I get no errors. I am going to fly too close to the sun and scooch it over to the left and see how close I can get it. So it's definitely pulling it the wrongish way. So
I'm getting all kinds of errors.
yeah, let's see. So I have that. Let me zoom in here. All right, it's not giving me an error like that. I think I'm going to just leave that the hell alone. Okay. So I've got my gates of MSU 3 and MSU 2 tied together, which is damn it, bring down my stupid little menu. I tied those together, and then I made a metal connection here. I know that the drain of MSU 2 and the drain of MSU 1 are supposed to be tied together, so that should just be metal from here to here. That's easy enough. And I just realized I need to press F5, so I have to connect them. Yeah. Nope, there are definitely times where it's just easier to just leave it the hell alone. No errors, okay. So I'm going to zoom way out here. All right.
What did you do at the top of the P-box? I missed that. That was a long time ago. Okay, so your bottom section to a-
Yep. So just a body connection, which for us would be a N-well connection. I'm going to zoom out more. You guys tell me when you're ready for me to start doing other stuff.
What size is the end line?
Let me see what you've got. move this down. Yeah, so when those two things, oh, no, there's one, two, one more. Now they have five, yeah. Yep, no error now. So it's just a gap between it was too wide, but you can. All right, how are we doing? Heads are,
I'm missing a bunch of like annotation.
that's for me, yeah, you can do that later, that's not particularly important, that's just my way of making sure I remember what's what when I'm trying to wire all this crap up.
Yeah.
Okay, so I'm gonna go back to our schematic here. So we just connected our source, or excuse me, our drain to our drain, which is this connection right here. So now we effectively have to connect this startup circuit to the beta multiplier circuit. So we need the drain of MSU3 to be connected to the gates of MB3 and 4. So what I am going to do is I'm going to take this whole, I'm going to zoom out actually, take this whole thing here and move it down just so that I don't have a very long metal run. And I'm moving it closer over here. So I need, let me double check what I needed there. First, I'm going to press F5. That's the wrong thing. F5, no errors. So I'm looking for my drain of 3 to be tied to my gate connection. So I put a contact here. I'm going to make it 10 by 5 so that it's wider. I'm going to connect this polysilicon gate out to this node, and then I'm going to line up this node as best I can and run metal down to here. And I want to get rid of those extensions because it's going to bother me. It's not doing what I wanted it to do. Or it's not looking how I want it to look. So that's definitely not what I want. Metal. Okay. I'm going to try to do the metal first. Is there something underneath here? What's that little node? Yeah, that's what the issue was. I'm just trying to line these things up well, connect metal to metal, figure out why it is extending like that, and it's extending oddly like that because it wasn't lined up as perfectly as I had wanted. And then I'm going to move this up. Thought I was going to move that up. And now I'm going to connect over to this polysilicon, and that looks like utter dog shit. All right, let's see what these errors are. Polysilicon 1 overlaps the contact. But I don't want it to be overlapped. I want it to be connected. Okay, so I just deleted it and then redid it, and it was just like, now it's not connected. So that'll work. Okay, so my drain, which I did not actually annotate, so I'm going to do that really quickly here. So this was the drain of startup 3. Down here was the source of startup 3. So my drain of startup 3 is connected to the gate of my beta multiplier transistor 3. So I've got that part done. So I just did this connection. So I had a little metal run, and then I did some poly over here. Okay. Now I need to connect the source of MSU3 to the drain of MB1. So the source of MSU3 to the drain of MB1. So here's my source. Here's my drain of 1. That's way larger than I want it to be. That makes me uncomfortable. That looks prettier.
What width did you mix up?
It's got a width of 4, but I took it from this part over here where it was skinnier.
Okay, because I just took that segment, which was 9, and made it 4.
I mean, I guess technically I could have just, instead of doing that route, I could literally just do this.
Okay, that's what I was gonna ask, because I didn't know like if there was a specific reason to do that.
Nope. Because that ties that, so just to be clear here, that's tying the source of MSU3 to the drain of MB1, which is tied to the gate of MB1, which is also tied to the drain of MB3. So yeah, I think that's an easier route to make. I'm going to press F5, no errors. I need to have my gate of MSU1 and my gate of MB1 tied together. And so right now I could tie them together with polysilicon like that. The only issue here is that that long run of polysilicon includes a run that's not going to get doped because there's no active regions or anything near it. So effectively, that's going to have a pretty large resistance that I don't want. So I'm going to delete that, and I'm going to make a short run out to here, connect metal. I bet these metals are too close together. They definitely are. All right, so that's as close as I can possibly do that one. I'm going to do something similar over here. I'm going to move this contact as close as I can make it without giving me an error. So this one doesn't have that extra run of metal, so it's going to get pretty friggin' close apparently. And then I'm going to tie those two contacts together. Not with polysilicon, with metal, you dumb jerk computer. Biscuits and gravy. Okay. So I have my startup circuit correctly connected to my, whatchamacallit, my beta multiplier. Now I'm just looking at things here. It does not look like I included a body terminal for MB1, which since its source is going to be at ground, that seems like a reasonable thing to do. So I'm just going to sneak that body connection down here. That'll be a P-well connection. 10x2. Move it over to where it lines up. No. Piece of shit. That anymore. I'm going to label that as
Okay, now I've got it.
B1 1.5. I'm not going to put a body effect or a body connection for MB2 because that body isn't going to be at ground. And so that's just going to make biasing things weird. So
You just added an inactive region there?
no, I added a P-well region.
Okay. Sorry, I was trying to fix some errors.
Yep, no problem.
Okay, yes.
So
I think it's pretty early.
Remember the video game I was telling you about last week? That's the exact problem I have with it. You can either have things pretty, have them working, you can't necessarily have them.
Yeah.
Okay, it's giving me all kinds of errors when I try to make that double connection.
which one?
One between the body connection on.
So it's because it's not considering it to be connected. So it's saying it's overlapped, but it's not connected.
Okay. I can delete that and try making a new connection. Yeah, good. I'd wash your hands after using it.
All right, I'm gonna go wash my hands.
All right, sorry about that.
No, it's good.
Oh, Lord. I don't know how, but I have what he has. He moves pretty quick. Yeah, so. Pretty. He moves extremely quick. Yeah. No, I just have, sometimes I'm like, okay, I'm just trying to keep up with what it matches up with on the schematic.
Thanks.
So I'm like, I think I know what I'm doing. I've learned some circuit design.
Yeah,
over the past few
somehow
years.
managed to get 0 errors.
Yeah. Making sure it's 0.
You know, I press that 5 and it's
Yeah.
0, 0, 0, 0, 0.
Yeah. Yeah, it's confusing because the wells and active leakings are almost the same.
Wait, so it's the fuel, right?
Well, especially on that screen, if you look close, they do have different patterns on them. It's just, I can't see it from the screen.
It just takes me a minute to decipher which one it is.
All right, so we need, you said it was a 26.5 K?
Yes, sir, 26.5 kilo ohm resistor. That's what my math cab is giving me, but
26.
So that's using the equation IREF equals 2 over R square of the square of the resistance variance
Mhm.
minus times beta 1 times width over length, right?
Yeah.
1 minus square root of 1, okay?
Yeah, so 26.5 kilo ohms, and high res poly has a resistance of somewhere in the ballpark of 1,000 ohms per square. So we need 26.5 squares in series. So right now, this thing has as I've drawn it, has a width to length ratio of 4 to 1. So this is effectively a 4 kilo ohm resistor ballpark. So if we did 6 of these, that would be 24. And then we did another one that was shorter, we could make it do the other 2.5-ish K. So I think that's what I'm going to do. I'm going to come down here and I'm just going to put 6 of these and try to wire them up. And then once I get it working correctly, so let's see what happens. If I press F5, I get 2 errors. The error says that they're touching. Does it matter if I actually connect them? Yes, so. Less, so they need to have a spacing of 4 between them. So it's 1, 2, 3, 4. All right. Res poly down here. Line it up nice and pretty. 1, 2, 3, 4. So if you go to preferences and you go to your technology node, make sure this little box that says analog is clicked down here at the bottom left. If it is clicked, you should have access to high res poly resistors. If you don't have it clicked, you won't have access to them because digital circuits don't use them. That's okay. Now they should be down there.
yeah, I probably should just copy that segment, moved it down, and connect them up again, have 2 separate, I mainly did all of them.
Oh, yeah, that'll work. Oh wait, that's gonna do.
Well, they're
It's
all
the
in
wrong-
position, though,
yeah.
so.
That's what I did doing.
All right, so now I'm trying to remember. Right now, so I should have done this before I copied them. The resistance of all of them is set to 0. So you have to click on each individual one and tell it what it is. So this is where you can actually kind of fudge things on a simulation as well. We're putting it in as if we're going to make this thing fabricated. You could literally just put 1 in there, say it's 26.5 kilo ohm resistor and call it a damn day. But if you actually set it off, it would not behave like a 26.5 kilo ohm resistor. Okay. So I'm saying that this is a 4K. And I'm going to make that text much bigger. I'm setting this resistance to 4K.
Holy crap, why is the text so freaking
I actually
small?
didn't even realize it was there. Like,
It's like.
I made mine 10 and it shows up quite nicely.
oh, yeah.
10 is
10 's
ridiculous.
very, but it's
That's
very
like, well,
visible.
I did
That's what
mine
I'm
on 10.
Okay, well, I'm being much more modest with 4K. So let's see, 4, 8, 12.
I don't trust my old man eyes.
I just don't have to do this old way. Hold on.
No, I don't want that. I want that selected. All right, so we need 2,500 ohms. So we need 2.5 squares. Right?
Hmm.
So a width of 25. Throw this guy down here. We make it 25 long by 10 wide, should give us 2,500 ohms.
This is how big it is.
25 length, 10 width, so that it's 2.5 squares.
I guess we should kind of center it. Or I guess it doesn't really matter.
Doesn't particularly matter.
I'm lining it up on the one that's connected.
Yeah.
That's what I did.
So now this is going to be connected. I'm going to move this up here, and I'm trying to line it up in the middle-ish. And I'm just going to see, so no error there. So I guess I'm just going to leave it there. And then this metal from our, hold on, let me think about this here. Because I was going to connect it there, but that's the drain, and the drain isn't supposed to be connected to that. The source is, so that would have made it work not correctly. I'm going to scooch this behemoth over to the right so that it lines up more with the source. And then I'm going to tie my source down to here. And this is gonna annoy me, moving one of them, every single one of them to the right. All right. So this will work. I'm trying to think about what could be done. So this is a big region of space that is effectively from this point all the way down, and then we're going to put our ground rail down here at the bottom. So we could have a large metal run go down to here to connect to ground so that we won't have much resistance from that metal one. Same here, that connects to ground.
If you move the connection up a little bit, it looks like you're gonna end up blocking some of these connections for everything on the right-hand side of the multiplier.
That's exactly what I'm trying to figure out, is if we're going to have a lot of space wasted in this region as we connect to the wide swing current mirror.
I mean, the alternative is if you put it on the left-hand side of your startup circuit, you'd have to run a longer metal one too, but you make that slightly wider. And then you'd have all that space to the right, and you could reduce the distance to your ground rail.
Yeah. But if it's a longer run of metal one to avoid, I'm just trying to think of.
Or we just don't need, we could. We've already built like a little serpentine path of resistors.
Yeah, but I mean, that's not a huge pain in the ass. Yeah, so I'm just trying to think from a space layout perspective. If we are throwing away too much space. I mean, there's empty space up here, but that very much doesn't make sense to utilize. Also, we have to have a metal one, or, well, we have to have a run connecting our power supply to this point, our power supply to this point, which we can use just very wide metal runs so that we don't increase the resistance seen between those 2 points by any appreciable amount. So that's reasonable. And the same thing here, we can have, you know, wide metal runs that extend over here down so that it's not really introducing a whole heck of a lot of resistance.
I just realized another problem what I was suggesting, you'd have metal ones crisscrossing.
So you could use other metal layers to avoid that.
That's true, but then you're adding complexity, and like we were discussing with the C5 process, not all foundries could do that.
Right.
So,
So I think the easiest thing to do here is to just leave this the hell alone. And then,
Well, this is fine electrically, right?
Yeah.
So we could understand how to compact this down. within reason, I think.
yeah, okay. So what I'm gonna do now is then put a long metal rail at the bottom. And so actually, I'm just gonna take our power supply rail and make a copy of it. See how well that lines up. All right. I'm just making these sections wider purely to make the resistance smaller. All right. So let me tell you about what I'm thinking about now, okay? So the only connection that's going to be made outside of this thing is the gate of transistors M1 and M2 needs to extend to the right to tie to other things. So what I'm thinking about doing is effectively, this is our beta multiplier with our startup circuit. And then we have our gate here, which is, I could select it. This thing over here. You know what? I'm going to do something slightly different here. Give me, let's see, polysilicon 1. Let's make it 10 in the X and for now 30 in the Y. So 30 is too much. So let's look at 26. How well does that match up with what we have down here? Pretty darn good.
So basically just creating.
A really big thing. Yeah. And then we're going to make a really large contact. So it needs to be 26 tall.
13 arrows.
I have,
Okay, how did you make the connection between the big node that you created and these eight?
all right. So let me delete that. Oh, shit. Delete that.
Okay, so you just made.
I made the big one. With it clicked, right click the polysilicon over here, and then I just
Okay,
scoot them over.
I didn't know if you made that connection like.
Yeah, and then now, so if I hit F5, I get no errors. I put a contact out here. I make this 26 and the Y. It's going to be connected to that same polysilicon. Right now, it's no errors. And I'm just going to keep moving it over to the left until I get an error and then move it back one more. And I don't want poly, I want metal. I'm going to do something similar here. So let's call this. Let's just do it 20 for now. Let's see, 26 minus 1 is 25. And I'm just literally just trying to have this extend over to the right past the resistors. So I'm just going to make that width larger. So let's see what happens with it. As a 50, not quite enough. 75. Yeah, not quite enough. 100. Oh, and it's extending on both sides, I think. No, it's not extending on both sides. It's not staying where I wanted it. Yeah,
So 50, so we'll talk like,
50 seems close enough for me. All right. So we have things. So I've got some metal up here selected. I'm going to press Control E and say that it is VDD, because that's where my supply rail is. I'm going to make this much bigger. Similarly down here with this metal connection, Control E, GND. Also make that much bigger. And with this metal thing, I'm trying to think of what I can do it. Control E, VG beta. So this is the gate voltage for the NMOS transistors for the beta multiplier. And let's make that 5 tall and export it over here. What I am, no, I'll leave this alone for now. That's just, we might come back and mess with this in a moment. All right, so one last press of the F5 button. No errors for me. Sounds like errors for other folks by the dammits going around the room.
Any more of that, I'm gonna get the horse to wash him out.
it was one thing.
Okay, so I'm gonna write this spice deck. So it can't find the model of one of the NMOS transistors, which means I didn't set the model of one of them. Let's see which one it was. So that one says NMOS, 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 PPP.
Okay, I think mine might have been, I labeled them lowercase when they're supposed to be capital. Or no?
Oh, I forgot to write spice code.
Oh.
That would definitely do it. Okay. Sorry about that. Spice code. So VDD, I think it's 0 DC 5. I need more than that. I think it automatically knows that ground is 0, so I'm going to leave that alone. This is going to be multi-line text. Let's see. Let's do a transient analysis just so that we have a plot as a function of time. I'm expecting DC values out of here, just so that we're aware. Just for the sake of argument, let's make it 1 millisecond, leave everything as blank. Dot include C:/C5, that is not 5, models.txt. Now that I've defined what the thing is, let's try this again. All right. No errors this time saying it doesn't know what things are, so that's a plus.
Okay, I think I just told it the wrong location for my text file.
All right, and then I want to know what my drain, hold on. Got so much shit going on here.
Tram.
Yeah, I did a transient analysis. I'm just trying to figure out what my my reference current is in this thing. And so I want to look at it at a couple of different places just to make sure things are looking legit. So this transistor right here, if I press Control I, is labeled as NMOS at 4. So that's one of them that I want to look at. So I'm going to go over here, add traces. And so this is going to be populated with just a wild number of things. ID of NMOS at 4. So this is my drain current for transistor M1. And I have negative 1.1 milliamp.
It's the line one, not the right transistor.
Drain.
Traces. So let me look at the current flowing through any of my high-res poly 2 resistors. That can be the direction. That's not an issue. The question here is we're aiming for 20 micro, and we're getting much, much larger. Let me delete this green one.
I can't get my lights spiced at all. BDD 0, DC 5, and then C : /C5 underscore models.txt.
Yeah, the fact that it's negative doesn't bother me because that just means it's choosing to do it in the wrong direction. It can't be an actual negative value, but the actual value is negative 117 microamps, which is about 6 times larger than it's supposed to be. So
Is the biasing resistor off?
that's exactly what my thoughts are due to parasitics and other things like that.
Also could be my math as well.
Also that possibly. So what I'll do sometime later today or before class on Friday is I'll play around with the values of things. Let me just pull up something real quick here. Oh God, what did I just do?
Dot, no, where do I put the dot include?
In front of the.
That's it. I forgot to tell what it was doing.
Or
Here it is.
open.
Got it. All right, that was it. Thank you.
Let me just see.
Single.
So this is an old beta multiplier that I made a while back, like a couple of years ago. Where's the thing to tell me where my errors are?
Mine kind of looks like it's closer to 20 microamps.
Oh, it went back to the old thing. Well, that's not helpful.
Does that kind of look like?
No, this is the one I want to look at.
In MOS number
Nope.
7, that's almost 20 microamps. Negative, of course.
This is all of your drain currents.
And that was not my intention.
Yeah, that's fine. Okay.
Yeah, but the red should be,
That's not that far off. It's like what, 50
18.
Yeah, assuming I have.
Class we ran out of time, so I'll play around with stuff over the next day or two and we'll figure out what's what there. It looks like I made this one slightly smaller by using multiple metal layers and all that kind of jazz. But yeah, that's what I did here, which it is what it is. What resistor?
Oh, yeah.
I'm using like 15 kilo ohms of resistance for this particular design. So anyway, yeah, we'll play it, or I'll play around with stuff and then we'll revisit things